Hi and welcome to another lesson. Thank you ever so much for the feedback from yesterday. It was really appreciated, and certainly for anyone that sent me an email last night, I will try and get back to you before the end of the day. Today we're going to be looking at a continuation of our learning from yesterday. Yesterday we were looking at how we expand over a single bracket, and today we're going to be looking at how we can expand two or more brackets that happen to be made up as part of a product. So today, as always, you'll need two things, pen and paper, and then secondly, open in a separate window. The link is in the description, hbkportal.co.uk/mwb/home. For this, that website is really key because it will allow you some extra practice a bit later on. So what were we doing yesterday? Well, yesterday I linked the learning that you had done previously in primary school of, say, 3 times 42 to how we might expand brackets. And to quickly recap on that learning, we said that in order to multiply 3 and 42, we might do 3 and 40, 3 and 2, and then add those two numbers together. And that same practice was when we had expanding brackets of algebraic terms. So 3 times x and 3 times 2 gave us 3x and 6. Now, as a quick recall, and this is where I kind of want to get you involved with this, on your pen and paper, what I'd like you to do is fill in the gaps that I've got at the bottom here. Now, this is going to be quite important because it means that you can kind of put anything you like on those dotted lines, but it will mean that you can actually self-check your understanding at this point as to how much you know of expanding over a single bracket. So I'm going to give you 1 minute in order to just quickly note down an example with any term you like in those on those dotted lines, and then see if you can expand it. And we'll, if you want to, use the comment section in order to post your question and your answer, and we'll see how well we have got on in a moment. So 1 minute, off you go. Okay, so I also had a quick go at this, and I've decided to put a couple of things. So I'm going to put 3 on the outside, 5x on the inside with -2. And the key part of this activity was to double check that we are multiplying both of the two terms inside of the bracket by the term that is on the outside. We could use the claw method if we wanted, which was everything on the inside is multiplied by 3, in which case 3 times 5x is 15x, and 3 times -2 is -6. Now, if you went on to come up with a really great example, Chloe's just come up with, which is 5 lots of x plus 6, she's then put 5x plus 30. Now, as a quick check, 5 times x is 5x, and 5 times 6 is 30, so well done. Okay, we've got some fantastic examples coming through now in the comments section, and I love this one. 5x on the outside and x plus 5 on the inside. So with this example, if we think about how we can multiply 5x and x together, well, this is where we need to introduce powers, because anything times by itself means squared. So x times x is x squared, and then I'm timesing it by 5, so I get 5x squared. If I then multiply 5x by 5, I then get 25x. So fantastic. I thought there were some great examples coming through on the YouTube comment section. Every single one of them is correct. With each of them, I can see that you have multiplied the terms on the inside by the number that is on the outside. So as a quick summary of what we learnt yesterday, that was exactly it. Multiply each term inside the brackets by the term on the outside. So We linked the learning from yesterday to a simple question, which was 3 times 42. But what if we had an algebraic product that looked like this? Would we represent this? So what if y happened to be 10? This question would now look like this, in which case 10 add 2, 10 add 3 would then give me 12 multiplied by 13. So thinking of some of the techniques that you would now use to be able to multiply 12 and 13 together, it could be that we go back to our good old favourite, the grid method. Or we could actually introduce perhaps a slightly adapted version of what we were doing yesterday through the claw method to now be able to work out this answer. So let's have a look at how we might do this on pen and paper. So thinking about if I had 12 multiplied by 13, I probably would use something like the grid method. 12 would be split out into columns, 13 would be split out into rows. Now every row needs to be multiplied by every column. So in this case, 10 times 10 is 100, 10 times 2 is 20, 10 times 3 is 30, and 3 times 2 is 6. And all of these numbers now need to be multiplied together to give me my final answer of 156. Now what if we then said, okay, well this is great, but what if I did choose to keep this as its broken up version involving brackets? Well, as you can see, the first box on this side actually meant that we needed to multiply 10 and 10 together, in which case we can see that if I draw an arrow to here, 10 times 10 would be this box here. So we've got our first arrow, 10 times 10, giving me this answer here. If I now draw in another arrow, 10 times 3, I can see that I've got this box. If I draw in an arrow from the 2 to the 10, I've now got this box. And if I now draw one last arrow to the 2 and the 3, I've now got this box of my grid method. And whether you call this foil, claw method, however you like, the basic principles of what we were doing yesterday still apply. That everything inside of the second bracket is being multiplied by the term that is on the outside. It just so happens that this time the term is another bracket. So how do we work this out? 10 times 10 is going to give me, following the same colour scheme, 100. And then we add on 10 times 3 is 30. Add on 2 times 10 is 20. And then finally add on 2 times 3, which is then 6. And adding all of these together, we get still the answer of 156. But it was a great way of actually just showing two different methods of getting the same answer that can be applied to the problem that we had to begin with, which is that if I now ask you to expand this, using either the column method or the grid method or the claw method, see if you can now come up with the answer to this. Let's see how many of you got it right. So with this question, y plus 2 multiplied by y plus 3. I'm going to use, first of all, the claw method, that y times y and y times 3. Everything in the second bracket is being multiplied by y. So I get y squared plus 3y. Now multiply everything in the second bracket by 2. 2 times y and 2 times 3 gives me 2y add 6. Now, normally what happens with these types of questions is that we'd phrase it as expand. But actually when we talk about expanding, we also mean and simplify. because when we look at the resulting expression from when we multiply the two brackets, the middle two terms will always simplify, especially if they've only got one letter in it, like y. So y squared plus 5y plus 6. So generally speaking, when you've got two brackets, we will simplify this together, and we'll have 4 terms from the expansion, 3 terms in our final answer. So what we need to learn from this is the fact that although we've got our success criteria from yesterday that multiply each term inside of one bracket by the terms inside of the other, when multiplying two brackets together, you will always get 4 terms from the expansion that can be simplified, especially if it only includes one letter or the same power, a lot like some of the examples that we're now going to look at. So I'm going to kind of fly through the questions on the left-hand side, and I'm then going to give you an opportunity to have a go with the ones on the right. So starting off with the first one then. So the first one, y plus 4 and y plus 5. If you didn't want to use the claw method with this one, that's absolutely fine. I'll perhaps use the grid method for the first one because I didn't show it in the last example. So I'm going to set up the first bracket along the top. So I've got my columns, and I'm then going to set up my rows as being y and 5. So multiplying every row by every column, I get y squared. So I've done the y times y. I'm then going to do 4 times y, which is this part here. Y times 5 is 5y, so I've multiplied y by 5, so I've multiplied everything in the second bracket by y. And you can see that the only thing that I'm missing now is the 4 to the 5. So 4 times 5 is now 20. So I end up with 4 terms, y squared plus 4y plus 5y plus 20. And then noticing that the middle two terms can now be simplified. Y squared plus 9y plus 20. So with this question, we can now think about kind of sticking with the technique that you feel most confident with, whether it be the claw method or the grid method. So moving on to the next one, w plus 2 multiplied by w minus 4. So using the claw method, w times w and w times negative 4 will give me w squared minus 4w. Now multiplying everything in the second bracket by positive 2, 2 times w and 2 times negative 4 will give me plus 2w and then minus 8. Noticing how the middle two terms again can be simplified, I get the final answer, w squared minus 2w minus 8. And that's it. Moving on to question 3. 2w plus 2, 3w minus 4. Expanding this bracket out, you'll notice that the coefficients of w is no longer 1. The number in front of w is no longer 1. That's fine, because we'll just need to adapt our answer a little bit in a moment. So let's do 2w, 3w. So 2 times 3 is 6, but w and w makes w squared. So 2w multiplied by 3w gives me 6w squared. The numbers in front is achieved by 2 times 3, and I've still got w times w, which is w squared. 2w times negative 4 is minus 8w. Now expanding 2 and 3, 3w and 2 and minus 4 will give me plus 6w and then minus 8. And same thing again, the middle two terms will simplify, so 6w squared minus 2w minus 8. And finally the last one, this one is a little bit trickier, simply because instead of having just w or y, we are having t squared plus 2 and t minus 5. So for this one, we're still going to use the claw method, even though visually it looks a lot more challenging. However, it doesn't so much matter, because when we still expand, the only thing we've got to remember is that if I had t squared, which is t times t, and I multiply that by t, I now get t cubed. Now expanding out the t squared and minus 5 gives me minus 5t squared. Still using the claw method, so 2 times t and 2 times negative 5 gives me 2t minus 10. Now when I look at the middle two terms of this one, you can now see why I was fairly careful in my explanation in saying that as long as there aren't any additional powers, you will always find that you can simplify the middle two terms. But because inside of one bracket I had t squared, and inside of the other I had t, hence different powers, I can no longer simplify the middle two terms, because t squared and t are on different scales, they are different numbers, so therefore we cannot simplify them. So what I want to do then is now see if we can push on to some practice questions for you. I will go through each of these practice questions in a moment, but the ones on the right are now for you to have a go at. So I'm going to stop for about 5 minutes and allow you, pen and paper, to start having a go. Whether it be using the grid method or the claw method, choose the one that you felt most confident with through some of my examples, and now have a go at them. I appreciate that obviously with the first one, I'm hoping most people will be able to access that, and as we move down, it will get a little bit harder because we are looking at some higher level algebra. However, give it a good go. That's the whole point of these videos, to try and push the boundaries a little bit. You've got 5 minutes. Off you go. Okay, so quite a few people finished there, and well done, James. We've got the 4 terms there correct. We just need to think about how we can simplify that one. So well done. Okay, so I'm going to go through each of these answers. Now I've set up the first one using the grid method to be able to see that along the top here we've got the first bracket, and along the side we've then got the second bracket. So every row needs to be multiplied by every column. So we do u times u, so that's that part, so that will give me u squared. We then do u times 2, that will give me 2u, so I multiplied the second row by the first column. We now need to multiply 3 by u, and that gives me this term here, and then 3 times 2, which is then 6. So as James has highlighted, we have got u squared plus 3u plus 2u and then plus 6. So you'll notice that with this one, because u is in 2 terms, we can actually simplify that to give me just 1 term. So I get u squared plus 5u plus 6. And that's my final answer. Okay, both of these are part of the method and the working, so we'd get 1 mark for each of those. Moving on to the next one, I'm going to use only the claw method with this. So I've got t times t and t times -1. So I'm going to break this up. So I've got t squared and minus 1t. I'm then going to multiply 3 and t and 3 and -1. So everything in that second bracket is now being multiplied by the 3. So we've got 3t and then minus 3. Same thing again, I've got 2 terms that involve t, so I can simplify this to give me just, the middle part can be simplified. So I've got t squared plus 2t and then minus 3. So on question 3, this is where it started to get a little bit harder, because no longer have we just got t, we've got 2t inside of one bracket and 3t in the next. However, let's move onto this using the claw method. And either one is absolutely fine, whether you use the grid method or the claw method, doesn't matter, because you'll notice that working out will still be exactly the same. So with this one, I've got 6t squared as being the product of 2t and 3t, and then 2t times -1 is minus 2t. 3 times 3t is 9t, and 3 times -1 is minus 3. Same thing again, the middle 2 terms can be simplified because they've just got t in it, in which case we end up with 6t squared plus 7t and then minus 3. Finally, the last one, and what I would consider to be a very hard one, so well done if we've managed to get this right. H squared plus 2h and then h plus 1. So with this, h squared is h times h, but if I'm timesing that by h, I get h cubed. H squared times 1, well, I've just got 1 lot of h squared, so that will just give me h squared. This one, 2h times h, will be 2h squared, and then this one, 2h times 1 is 2h. Now with this one, the 2 middle terms this time do simplify together to give me a term involving h squared, so always look out for this. So we've got h cubed plus 3h squared and then plus 2h. So well done if you got all 4 of those right, but my basic expectation out of today's lesson is actually, if we are feeling confident with the first 2, that's absolutely fine. The other 2 are merely there as an extension. Now, as a quick reminder of some of the things that we've been discussing so far, here is a very quick summary again. So everything inside of the second bracket is multiplied by everything inside of the first. And always look to see if it can be simplified. But in much the same way as I was mentioning a moment ago, that the last 2 questions in the previous examples were kind of like my extension, I'm pretty sure that some of you are now thinking, well, if this method works for 2 brackets, could it possibly work for 3? So what if we had a question that looked like this? Well, this is something that I'm going to ask a few of you to explore in the next section of our lesson. Reason being, I'm going to move over to the MWB site and ask you to get some extra practice with this. So, moving into the site, we should have something that looks like this. So follow the link in the description, hbkportal.co.uk MWB /home. If you open this up in a separate window, you'll be able to have not only the video and then also this site as well, side by side. Now we need to search for expanding brackets. So I'm just going to start typing for expand. And there's our content from yesterday's lesson, and we need to select the one that's just beneath that. So selecting the single star, you'll notice that it comes up with a question very similar to what we've just been practicing. Just as a recall, pressing the 1 star button will keep refreshing the question. And if you want the answer at any point, you have got the answer button there, so you can double check how well you're doing at every stage. If we move into the 2-star one, this is where we've added an extra layer to the question, because now it's not just positive numbers, we've got a negative in there as well. And if we move into the 3-star ones, you'll notice that there is something familiar about what is in both of those brackets. That's something to explore in a moment. 4-star, again, it gets a little bit harder. 5-star, we're introducing powers, so if you need a little bit more practice with that. And then finally, the 6-star question is involving 3 brackets. And as you can see, we're expecting the answer to look fairly more, a little bit more complicated, because it has got 3 brackets in it. But we've got plenty of opportunities now to be able to rehearse some of the skills that we have looked at in today's lesson. I'm going to leave this screen up so that anyone that wants to work off these questions as opposed to using the site, that is absolutely fine, because certainly if you're on a mobile or a tablet watching this video, as soon as you move away from YouTube, you are going to struggle to have both up. So I'll leave this up and we'll go through the answers. I'm going to give you about 9 minutes now to have a go at this question, these questions, and on pen and paper. That'd be great. Off you go, 9 minutes. Okay, just to deal with a couple of questions that have come through on the YouTube chat. Yes, when I multiply a negative and a negative together, it does give me a positive. I will post the link in the comments again so that for anyone that is unsure, you can click on the link and open up the site in a new window. Okay, just over 3 minutes left. Okay, last minute. Okay, so let's go through the answers then. So with the first one, we've got x plus 6, x plus 5, and the answer is x squared plus 11x plus 30. Moving on to the next one, x minus 2, x minus 9. When we multiply it out, we get four terms, which are x squared minus 9x minus 2x and plus 18. So the middle two terms in that case would then simplify. Well done to James, who managed to identify that the middle two terms of this one actually cancel out. So when I simplify this one, we've got a special case where we've actually got x squared minus 16. We'll have a look at that in a moment. The next one, when we expand this out, we get 32x squared plus 7x plus 35. Well done to a number of you that jumped straight into the 5-star questions. The answer to this one was quite a tricky one. 12x to the power 5 plus 12x cubed plus 30x squared plus 30. And I will obviously highlight at the moment that there are a good number of year 10s and year 11s, especially if you're sort of sat there in year 7 or year 8 at the moment and watching this video trying to have a go at this. They would also struggle with this style of question. So well done if you did get those right. And then finally the last one, how do we answer this? Well, I'll go through that one in a moment, but the answer is x cubed plus 12 to x plus 35. Now we saw the answer to the next one on the screen, but I'm really conscious that quite a number of people are now asking about how we answer that last one. Well, with this one, I actually deal with the first two brackets to begin with. And then what we do, let's just get the answer. So it will be x squared plus 5x, and then plus 2x, and then add 5. So the answer to the first two brackets, 10. First two brackets is x squared plus 5x plus 2x plus 10. So simplifying the middle two terms, we've now got this. Now obviously I've only answered the first two brackets, but if I now put this in brackets and times it by x plus 5, you can see that what I've got is a slightly longer question now, but exactly the same process. Everything in the second bracket needs to be times by everything in the first. So we naturally now draw 3 arrows, and this is where it's going to look incredibly messy. So perhaps I'll get rid of my previous line of work just to fit in all of my arrows. With this one, we do x squared times x and x squared times 5. So I get x cubed plus 5x squared. I now need to multiply everything in the second bracket by 7x. So it will be 7x times x is 7x squared. And 7x times 5 would then give me 35x. We now need to multiply everything in the second bracket by 10, so 10 times x and 10 times 5, so it will be 10x add 50. So we now look for the things that can be simplified, and as you can see here, we've got these two terms and these two terms can be simplified. So my answer, x cubed plus 12x squared plus 45x plus 50. And I can tell you now, it makes you feel like an absolute champion when you answer one of those questions and you do get it right. So well done for anyone that is going to have a go following this video at those questions. So let's think about wrapping this up. So we've just looked at the what if we had three brackets, and we've also kind of covered a number of things. Essentially, multiply every term in the second bracket by the terms that are in the first, and always look to see if you can simplify your answer. Now, if this was an exam style question, these are the types of ways that it could be posed to you. So last couple of minutes, all I want you to do is just have a look at this and see if you can have a go. The last one is a problem solving question, so a little bit beyond what we've done in today's lesson, but hopefully when you look at the first one, we should be able to do that one and gain one, if not both marks. So a couple of minutes, just have a quick go, pen and paper, off you go. Okay, so let's just go through this. I can imagine at some point you're thinking, my brain hurts. This is an incredibly difficult skill, especially when in terms of algebra, and a real leap up from what we were looking at yesterday. So let's go through these answers and just reflect on where some of the marks might come from. So looking at the first one then, I'm still going to use the claw method, even though the second bracket has been slightly rearranged to how it's been presented for much of today's lesson. Exam papers will often try and produce questions that are a little bit different to perhaps what's practiced in class, and that's certainly reflected in the second question from the exam ones that I've posted a second ago. So 8x times 5 is 40x, and 8x times negative 2x is minus 16x squared. Negative 7 times 5 is minus 35, and negative 7 multiplied by negative 2x is positive 14x. So this is all jumbled up at the moment, so I'm going to rewrite it in descending powers of x. So minus 16x squared plus 40x plus 14x, and then minus 35. And here you can see, now that it's written in descending powers, I can see that the middle two terms will simplify. So it's minus 16x squared plus 54x, and then minus 35. So in terms of marks, I'd get a mark for correctly expanding out the brackets, and the terms could be in any order as long as obviously the sign in front of them stays the same as how I've presented it in this question, and then we get a mark for the final answer. So moving on to question 2 then. For this, I needed to work out the value of a, and it said that x plus a all squared is equal to x squared plus 8x plus 16. Now this is slightly different to some of the questions, which is why I wanted to go through it in the final section of today's lesson, because here we've actually got the things inside of the bracket, both being algebraic terms. However, x plus a all squared means nothing short of x plus a and x plus a multiplied together. So if I follow exactly what we've done in today's lesson by expanding this out, x times x is x squared, x times a is ax, a times x is ax, and a times a is a squared. So now when we look at this and we simplify the middle two terms, x squared plus 2ax plus a squared. Now what I can do is I can compare the numbers in my question. So plus 2a has to be the same as 8. A squared has to be the same as 16. And obviously a is the same number in each of these. So I could now solve either one of these and get the value of a. Let's stick with this, that if 2a is equal to 8, a must equal 4. And that's true because if I do 4 squared, that gives me 16. So there we go, a is 4. So we've now gone through a wide range of different skills in today's lesson, and we really have covered an awful lot relating to the topic of expanding. So let's just finish off by saying thank you for watching. Please give me a thumbs up if you liked it, a subscribe if you loved it, and by all means please use the Pixel Maths app for extra practice, and you can search for these topics under Take a Test. Or please do go back onto hpkportal.co.uk/mwb/home in order to get some extra practice based on those differentiated questions. See you next time.